Welcome to How to Use the Sonos PD Alert. Course objectives. First, we'll start with the introduction. Then we'll discuss what is partial discharge. We'll get into the features and benefits of the Sonos PD Alert, and then we'll get into a detailed list of how to use and set up your Sonos PD Alert. Hierarchy of controls. The goal of any solution is to provide the maximum amount of protection by eliminating or minimizing the exposure or hazards to an inspector. These are referred to as the hierarchy of controls, and this covers how you prevent or control a hazard, either through elimination or substitution, with the main goal for any fix to a hazard or exposure is to eliminate it altogether or substitute a product or method of doing the work to a less hazardous alternative. The problem: in any network, the vast majority of assets are distributed via secondary substations, taking high voltage down to low voltage for consumer supply. Often, these assets are low in value but high in volume. Therefore, it's difficult to include in a condition monitoring program. Traditional monitoring is too expensive. Spot testing cannot cover the high number of assets. The Sonos PD Alert addresses these issues. It's designed for a large-scale rollout, and it is now a cost-effective system for PD monitoring over such a large asset base. To highlight the intended sites in which the Sonos PD Alert can be deployed, the example to the right shows a number of substation assets in a typical large city. The Sonos PD Alert is designed for these secondary substations and is the only solution currently on the market for customers to monitor these assets cost-effectively. The Sonos PD Alert offers a site the ability to remotely monitor for partial discharge events in the transient earth voltage and ultrasound range. The Sonos PD Alert is an asset-mounted device for indicating the presence of partial discharge in high voltage switchgears, ring main units, better known as RMUs, and dry-type transformers. It's designed for use in small substations. The instrument can activate locally and remote alarms in addition to local indications. The Sonos PD Alert can monitor using data synchronization to a central server, log and trend PD activities against asset history, automatic data integration with SAP, automatic high PD alerts to asset management teams live from the site, and integrated noise deduction algorithms help to avoid false positives. Some of the key features revolve around the display, which can also show in ultrasonic and TEV levels and decibel values. Alarms with a current live alarm and historical alarm. TEV PD detection measurement of the electrical transient generated by the internal partial discharge. Ultrasonic PD detection with 3 independent ultrasonic channels detecting surface PD. Integrated noise detection algorithm will again help prevent false alarms, and it's simple to install. No wiring required between PD detector and central hub. With 2 types of sensors, the TEV sensor, better known as the transient earth voltage transducer, is external to the unit to measure the internal PD. The ultrasonic transducers are connected to the unit and positioned around the substation. So what is partial discharge, you may ask? Well, it's an electrical discharge that does not completely bridge the space between 2 conducting electrodes, and 80% of failures in switchgear are directly related to partial discharge events. These partial discharge events can be caused by gas-filled voids in solid insulation, which are bubbles in the jacketing of the cable, which can lead to failure over time. These voids can be caused by substandard cabling manufacturing or environmental exposure. Partial discharge may be found in liquid-filled transformers where the paper insulation starts to degrade with exposure to high heat levels. This will lead to oil losing its insulation value, and the degradation of cellulose paper becomes more rampant. This produces bubbles in the oil, which allows the conduction of current inside the equipment, which in turn will show as TEV and ultrasound indications. Partial discharge can even occur around the connections and insulators on transformer lines or in substations. Chemically, the discharged energy breaks down the chemical bonds of oxygen atoms, which in turn produces nitrogen oxide. This will leave a white powdery substance around the anomaly that, if exposed to moisture, turns to nitric acid. Partial discharge activity inside metal-clad high-voltage gear includes small voltage impulses called TEV, or transient earth voltage, across the surface of the metal panels. TEV travels around the surface to the outside of the switchgear, where they can be picked up using externally placed partial discharge detection devices like the Sonos PD Alert. There are 6 types of partial discharge that can be detected using TEV or ASU devices. Infrared will pick up 2 of these, which in turn helps to prove the exact fault condition occurring inside the asset by process of elimination and correlation. We discussed already the ionized bubbles occurring in oil-filled transformers. We also covered insulation voids and what they can do. We discussed corona. Now let's discuss treeing. Treeing occurs as the current from the fault condition begins to migrate out and away from the source across a normally insulated surface without bridging the gap. This will be detectable using TEV and ASU devices. Tracking occurs when a continuous conductive path has been established across an insulative surface. This path allows for the current to creep across the surface in an attempt to find a path to ground. This will produce TEV, ASU, and infrared indications. Arcing occurs when electrical current jumps from one point to another. This can happen with or without treeing or tracking prior to the event. This too will also be detectable using TEV, ASU, and infrared technology. Sound analysis can also be a key determining cause of the exact fault condition that's present when looking for these 6 partial discharge events. They will each have a distinct pattern when viewed in software, and in a time signal analysis versus the frequency spectrum. These distinct images, in conjunction with the PRPD screens and level modes, allow the inspector the ability to make a decision about what steps to take next in the asset's health. So what do decibels and TEV indicate? Well, the Sonos PD Alert can detect decibels from -6 to 60 decibels. As the voltage spikes and the incident wave strikes the earthen metal of the cabinet, they produce a detectable TEV at a range of 0 to 200 plus megahertz. Colored LEDs indicate the level of intensity. When operating in TEV mode, values between 20 to 29 signal a medium level of partial discharge event. 30 decibels and higher indicates a high level of partial discharge event in the TEV realm. Non-TEV anomalies are shifted and displayed as noise on the display screen. When operating in AE mode, values between 20 to 29 decibels indicate a medium level of PD is occurring. Greater than 30 decibels would indicate the presence of a high-level partial discharge. Indications can be followed up with a handheld device that can record and analyze ultrasound emissions for the exact fault condition. How to use the Sonos PD Alert. Section 1. The Sonos PD Alert is an asset-mounted monitoring device for detecting the presence of partial discharge in high-voltage switchgear, ring main units, better known as RMUs, and transformers. It is suited to a wide range of different applications within a substation using 4 sensor inputs, which can be configured with 1 capacitive coupler for TEV detection and 3 AE ultrasonic sensors to accurately detect the presence of PD. The Sonos PD Alert allows the user to set up notifications and alerts for PD activity in particular assets. Once PD activity reaches a preset level, the Sonos PD Alert will send remote SMS alerts through a GSM module. The Sonos PD Alert data may also be monitored by connecting to a SCADA system. This allows SCADA users to integrate the Sonos PD Alert into their existing systems to allow for a seamless approach to PD monitoring within an existing SCADA network. The Sonos PD Alert is a non-intrusive online monitoring device which can be set up, commissioned, moved, and redeployed without interruption to substation assets and can continuously record data while the equipment remains live. Section 2. Partial Discharge. Partial discharge, again, is an electrical discharge that does not completely bridge the space between 2 conducting electrodes. The discharge may be in a gas-filled void, in a solid insulation material, in a gas bubble, in a liquid insulator, or around electrodes in a gas. When partial discharge occurs in a gas, it's usually known as corona. Partial discharge is generally accepted as the predominant cause of long-term degradation and eventual failure of electrical insulation. As a result, its measurement is a standard as part of the factory testing of most types of high-voltage equipment. In-service monitoring of equipment for PD gives an advance warning of pending insulation failure. This allows a plant operator to take remedial action during planned outages. Partial discharge often occurs under normal working conditions, gradually deteriorating the dielectric until it can no longer withstand the electrical stress and fails. By detecting this PD activity while the equipment is in operation, failure can be avoided. Section 2.1, Radiated Energy. A PD event will radiate energy in different forms, and this energy can be picked up by the PD detector in order to detect the source and locate it. Section 2.1.1, Electromagnetic Radiation. PD creates EM radiation that dissipates in all directions away from the source. Metal components, for instance, the panels around the switchgear, will pick up the radiation in small voltages called transient earth voltage, better known as TEV, and they are induced along the surface. These very high frequency signals will be picked up by the PD detector and indicate that there is a PD source nearby. Section 2.1.2, Acoustic Radiation. Partial discharge also generates acoustic energy across a wide band of frequency. This acoustic energy can be detected in ultrasonic range when there is a line of sight between the PD source and the detecting sensor. Sharp points, for instance on air-insulated cable terminations, are typically sources of corona that will produce acoustic emissions. Cast insulators are prone to surface tracking, where electrical stresses across the insulator surface cause discharges and deteriorates the insulator's surface and creates carbon tracks. This can lead to flashover and failure of the equipment. Section 3.1.1, Dimensions. The Sonos PD Alert has the following external dimensions, excluding attachments and aerials. It has a width of 230 millimeters or 9.055 inches. It has a height of 195 millimeters or 7.677 inches, and it has a depth of 65 millimeters or 2.559 inches. Section 3.1.2, Weight. The Sonos PD Alert weight is only 660 grams, or 1.45 pounds. Section 3.1.3, Power Supply. The Sonos PD Alert is supplied by 110 to 250 VAC or 47 to 63 Hz PSU. In the event of a power failure within a substation, the Sonos PD Alert also has a built-in lithium-ion battery, allowing for continued alarm capability. Backup battery life is variable depending on the amount of data being received by the sensor. Section 3.1.4, Temperature. The Sonos PD Alert can be installed in the following operational temperature ranges, from 0 to 55 plus Celsius to 32 to 131 plus Fahrenheit. Section 3.1.5, Relative Humidity. The Sonos PD Alert can be installed in the following relative humidity operational ranges, from 0% to 90%. Section 3.1.6, Connection Types. The Sonos PD Alert is configured with the following physical connection types: 3 active BNC connectors, 1 passive BNC connector, and 1 SCADA network connector. Section 4, CE Compliance. The Sonos PD Alert system complies with the following directives: EN 61000-6-2 2005 Immunity Standards for Industrial Environments, EN 61000-6-3 2007 Emission Standards for Residential and Commercial and Light Industry Environments. Section 5, the Sonos PD Alert Kit List. The Sonos PD Alert Kit includes 1 Sonos PD Alert, 1 Sonos PD Alert Power Supply, 3 ultrasonic PD sensors, one capacitive coupler TEV PD sensor, one GSM aerial antenna, 4 sensor cables, one Sonos PD Alert manual. Section 6. General Substation Safety Precautions. Before setting up the Sonos PD Alert in the substation, it is important for the users to read and understand the following general information. The engineer should obey the plant owner's high voltage safety rules at all times. The following safety rules, which are particular to the Sonos PD Alert equipment, should be applied in addition to the existing safety rules, which are required by the plant owner. General safety rules for the use of the Sonos PD Alert are as follows. Avoid working alone. Only accredited personnel with appropriate health and safety training should use this equipment. Do not use the equipment if it is damaged or its safety is impaired in any way. Inspect and test all ground leads and signal cables for continuity. The user should have read and understood the appropriate equipment manuals. Always select the appropriate sensor and sensor connection for the application. The Sonos PD Alert has been designed for use on the earthened outer surface of metal cladding equipment and the earth neutral connection of cables. Under no circumstances should the sensors be connected to the high voltage terminals of a high voltage asset being tested. Always maintain a safe distance between the Sonos PD Alert, PD sensors, and the operator and high voltage components. Do not disturb or interfere with the high voltage equipment in any way. The user should wear sensible and appropriate PPE and clothing when in substations. Section 6.1 Access. The CBM engineer or CBM analyst shall only enter the customer switchyard or substation after they have received permission from authorized personnel appointed by the plant owner. If in any doubt on any matter, the plant owner's high voltage system rules should be consulted by the CBM engineer or CBM analyst who will be carrying out the testing. Section 6.2 Visual Inspection of Substations. On entry to the monitoring area, a visual inspection of the area should be carried out by the CBM engineer or CBM analyst. This should enable the operator to identify any potential hazards in the area and to assess both the equipment to be monitored and the sensors required to do so. Only when this visual inspection has been completed can the equipment be set up for monitoring. Section 7. Environmental Protection. At the end of useful life, the Sonos PD Alert should be properly disposed of. This product contains general electronic components that may be environmentally harmful if improperly disposed. Please use correct disposal methods in accordance with local regulations. Section 8.1 Sonos PD Alert Outline. The Sonos PD Alert has a solid ABS casing which can be magnetically coupled to the surface of a switchgear cabinet. The Sonos PD Alert can be configured with one capacitive coupler TEV sensor and up to 3 AE ultrasonic sensors to collect and monitor PD signals, which are collated through the specially integrated noise detection and rejection algorithm, which helps eliminate the potential for false positives and unnecessary alarms. The Sonos PD Alert will locally display any alarms on the OLED that have been sent to the connected remote tablet, as well as any current, previous readings, or trends. The Sonos PD Alert can be configured to send alerts to designated asset managers who can also receive a computer-readable PD report, which can be opened through the Sonos PD Alert's accompanying Android tablet app. These reports can be used to assess remote assets that may be difficult to include in a regular testing schedule due to their location or tight schedules of test engineers. The small design and magnetic coupling of the Sonos PD Alert allows it to be repositioned or reconfigured to suit different substation assets. Section 8.2 Sonos PD Alert Unit. The Sonos PD Alert is encased in a small but steady ABS housing and features a membrane control panel. Below is a complete overview of the Sonos PD Alert and its connectable accessories. Number 1. The power button. Pressing and holding for 2 seconds will turn the unit on or off while using the secondary power supply. While connected to the main power supply, the unit will not power down, and this is to prevent accidental shutdown. Number 2, OLED display. This displays ultrasonic and TEV signal levels as collected by the attached sensors. It will also allow the user to navigate various menus and settings of the Sonus PD Alert. 3. Reset alarm. This deactivates and resets any ongoing alarms triggered by the Sonus PD Alert unit within its set parameters. 4. Menu up button. This navigates the Sonus PD Alert's menus or moves up through the letters selections. 5. Back button. This navigates the Sonus PD Alert menus to previous screens. 6. Menu button. This navigates the user from the current screen to the main menu button. 7. OK button. This confirms the user's current selection to navigate forward through the menus or confirm letter selections and number inputs for naming of the assets. 8. Menu down button. Navigates the Sonus PD Alert menus or moves down through the letter selections. 9. TEV channel input. Connects to one TEV sensor. 10. AE ultrasonic inputs. Connects for AE ultrasonic sensors up to 3 times. 11. SCADA output. This connection is for communicating with the SCADA system. 12. Power input. This is where the PSU input plugs into the body of the Sonus PD Alert. 13. GSM aerial. This allows for inserted SIM cards to send SMS messaging to designated users. 16. Ethernet port. Allows user to connect to the Sonus PD Alert to their internal networks. Currently not shown in this image, however. 14. AE ultrasonic sensors. Sensors for collecting ultrasonic frequencies emitted by PD. 15. Capacitive coupler for TEV sensors. Sensors for collecting transient earth voltage signals emitted by PD. Section 8.3 Sonus PD Alert Installation and Setup Options. The Sonus PD Alert's simple design allows for easy installation and portability of the system. The Sonus PD Alert will magnetically couple with any switchgear panels or may be affixed with screws to a wall using anchor points. The connected AE ultrasonic sensors and the TEV sensor are also magnetically mounted onto the asset, so it can be moved quickly and easily to new positions to optimize monitoring conditions of different assets. Section 8.3 Sonus PD Alert Installation and Setup Options. Once the Sonus PD Alert has been placed on or next to the desired asset and the detection sensors have been reconfigured on the correct switchgear panels, the sensors need to be thoroughly tested to ensure the data acquisition is correct. This can be done by using the installation checker. The sensors can be checked using the installation checker with each sensor through the live cycle mode of the Sonus PD Alert. Each channel is checked using the live cycle PRPD function of the Sonus PD Alert, and the installation checker will produce a signal that each sensor should collect when functioning properly. The PRPD system will register a moderate decibel level, which means that the sensor is functioning correctly. Once the sensors have been checked and are confirmed to be in working order, the Sonus PD Alert can be set up with alarm thresholds and alert information. Section 8.4 Sonus PD Alert Local Setup. Once the Sonus PD Alert has been powered on, it will display a current TEV reading and the current highest AE reading recorded for all sensors. It will also display whether the Sonus PD Alert has synchronized with the power cycle. This will be the default screen when the menu is not active. The Sonus PD Alert is controlled using the membrane control panel on the front of the unit and the navigation menus. Any of the following steps can be used to set up the Sonus PD Alert or reconfigure the Sonus PD Alert. The main menu. From the main menu, pressing the menu button will take the user to a main menu where several options are available. To continue with the setup of the Sonus PD Alert, move down to the settings and press OK. Monitor setup. From here, the user will be able to select several different Sonus PD Alert operational settings. Selecting monitoring setup will take the user to another screen with another monitor detail. The asset name feature will allow the user to set an asset's name. This is recommended in order to differentiate Sonus PD alerts that may be used as part of a monitoring network rather than individually. An asset name can be entered by using the up and down arrow and the OK button to confirm letters and numbers. An asset name can be a maximum of 21 alphanumerical characters. Once the asset has been entered, it can be confirmed by pressing the back button. A server number can be entered in the same manner as the asset name. The server number is a mobile phone number which the Sonus PD Alert will use to report its heartbeat notifications and PD warning alarms. Each AE channel can be specifically named to assist in differentiating which sensor is collecting signals. This allows for easier recognition of PD signal source location by naming the panels the sensors are monitoring. Depending on the configuration of the Sonus PD Alert, there may not be a requirement for all 3 AE ultrasonic channels that are part of the Sonus PD Alert system. To reduce the number of AE channels the Sonus PD Alert uses, follow these steps. 1. There must always be at least 1 AE channel in use. 2. The total number of AE channels can be set between 1 to 3. 3. After the channel settings have been confirmed, the user can return to the setup menu to verify. 4. From here, using the back button, it is possible to navigate back to the main menu. The operating mode of the Sonus PD Alert sets the observation period parameters on which the Sonus PD Alert sends out the data that is collected. If no PD activity is detected, the unit will continue to send out its heartbeat notifications where 1 has been set. If the PD activity is equal to or above the predefined level, the Sonus PD Alert will send an alert to the preset users. The observation period can be set to the following. 1 minute. This should be used for demonstration and test purposes only. 1 hour is recommended for periods where workers may be in the area near the switchgear as a safety precaution. 1 day is recommended for highly critical assets where failure would result in major disruption to a distribution network. 1 week is recommended for critical assets where failure would cause moderate disruptions for the distribution network, and 1 month is recommended for less critical assets where long-term reliability is still important. Once the Sonus PD Alert has been given an observation period, it will only report once the unit has been booted up for the observation period set. If the unit is powered down during the observation period, the Sonus PD Alert will be unable to analyze the collected data or run the PD decision algorithm. When booted up again, it will restart the data processing and will continue to follow the same parameters as set prior to the unit being powered down. The alarm setting menu allows for further tuning of the Sonus PD Alert's notification settings and allows for full customization. This menu also allows the user to configure the SCADA connection for better integration into the user's system. Threshold settings. The user can set 3 levels of PD activity, low, medium, or high, that are required to register different SMS alarm levels that'll trigger an alert notification. Once the numbering values have been saved, the recommended default will be lost until the Sonus PD Alert undergoes a factory reset. If while entering the value the user does not press OK or presses the back button, the amended values will be lost. It is only recommended to adjust the threshold value when the user is aware of how the levels correlates to the asset's risk. Startup settings. The user can set the Sonus PD Alert to run the decision algorithm at boot up, which will then analyze data from the previous observation periods. It will then trigger any relevant alarms and recommence monitoring with a new observation period. It is recommended that this option is always enabled. The SMS settings menu lists several submenus which directly control the type of SMS alerts and the data contained within the notifications it sends. All notifications will contain basic information such as Sonus PD Alert serial number, time and date of the notification, operating mode, i.e. what observation period it's in, SMS alerts, its alarm or heartbeat, temperature and humidity levels, maximum PD level collected during the last observation period, maximum noise level collected during the last observation period, highest TEV PRPD collected during the last observation period, and the highest AE PRPD collected during the last observation period. All levels in PRPD samples will be coded so the Sonos PD Alert app is able to decipher the information, or an IRISS CBM engineer will be able to assist you. The SMS status menu allows the settings to be toggled on or off. If no SIM card is inserted in the GSM module or no mobile number has been input, then enabling this option will have no effect. If a SIM has been inserted or a mobile number has been entered, SMS notifications may still be disabled. If disabled, the Sonos PD Alert will only act as a monitor, and any information will only be available locally or via Bluetooth. No remote alerts will be sent. SMS human readability changes the format of the SMS alerts to either a human readable format, allowing the user to define whether they receive information directly via SMS, or a machine readable format. Human readable format will not include PRPD samples, but will have enough information to determine the asset's health for the alert. SMS events allow the user to choose when they will receive SMS notifications. There are three options that are available: off or never. The Sonos PD Alert will not send notifications even in the event the PD activity is detected during the observation period. EVE, or event only, the SMS notifications will be sent at the end of the observation period. And AWL, or always, the Sonos PD Alert will always send a notification via SMS at the end of the observation period, even if no PD activity is detected. After selecting the type of alert the user wants to receive, press OK, and this will save the alert settings. Heartbeat. The Sonos PD Alert can send a regular notification to users via SMS. These act as a heartbeat for the Sonos PD Alert. This feature is especially useful when the Sonos PD Alert is configured to communicate with a remote server to ensure that the Sonos PD Alert is reporting correctly. The remote server can be configured to send alerts when the Sonos PD Alert fails to send a heartbeat notification. The heartbeat is configured to send an SMS approximately once every 24 hours. There is a slight offset to ensure that these heartbeats will not coincide with normal observation periods, as the Sonos PD Alert cannot send multiple SMS messages simultaneously. Encoding. The user can select to have the TEV PRPD patterns coded as a single pattern by turning the encoding off. If the encoding option is set to standard, the Sonos PD Alert will encode each PRPD individually. SCADA system. After the SMS settings have been confirmed and the user has returned to the monitor setup menu, it is possible to enable a SCADA connection with the SCADA channel menus and turn options from off to on. Once SCADA has been enabled or shut off, it is possible to return to the main menu with the back button. Bluetooth. The Sonos PD Alert is equipped with a Bluetooth module which allows it to communicate with any smart devices that are set up with the Sonos PD Alert app. For the Bluetooth menu, the user can set a Bluetooth pin, allowing the Sonos PD Alert app to run on a remote device. After entering the desired pin number and pressing OK, the Sonos PD Alert will need to be restarted for the pin to be verified with the Bluetooth module. Once the pin has been set, the user will only be able to connect with the Sonos PD Alert using this number. Language settings. The Sonos PD Alert can be set up to one of a number of different languages. These are the ones that are currently available: English, the default language, French, German, or Spanish. After selecting a language, the Sonos PD Alert will display in and send notifications in the chosen language. To confirm that the Sonos PD Alert has been configured correctly, the user needs to ensure the status of the SIM card, signal strength of the GSM, and run an SMS alert test. Status. This displays the current status of the SIM card in the GSM module. If the SIM is functioning correctly, it will display the SIM information. If the SIM or GSM module are not functioning correctly, the user will receive the message "SIM card not registered," SIM card not inserted, or GSM module not detected. SIM card not registered. If the user received this error message, there is a problem with the SIM network carrier or the account associated with the SIM. Please contact the network carrier and try again. SIM card not inserted. If the user receives this error message, please ensure that the SIM fits firmly in the GSM module with the chip pressed against the contacts. If there is room for movement of the SIM, this can be remedied by using a small wedge to secure the SIM card. GSM module not detected. This indicates that there's not enough signal strength in the present location that the unit has been positioned. The repositioning of the antenna may improve the signal being received by the Sonus PD Alert. In some cases, larger antennas may be required due to the thickness of the walls or the location inside the plant that the Sonus PD Alert is positioned in. This can also be caused by not properly reinstalling the SIM PCB after installing the SIM card. Signal test. Displays the signal strength being received by the SIM card. It is recommended that the Sonus PD Alert has at least 50% signal strength. If the signal is weaker than this, the Sonus PD Alert may not be able to complete SMS communications with the server. To refresh the signal level, the user will need to go back to the previous screen and try to re-enter the signal screen. Test SMS. The user can send a confirmation SMS to a location defined in the server number, which causes the Sonus PD Alert to send a test alarm SMS. Once this message has been received, the Sonus PD Alert is fully configured and in working order. Section 9. Sonus PD Alert Service Menu. The service menu in the Sonus PD Alert has further information and operation options for the user. The Enter Calibration option is only accessible by IRISS engineers who can ensure the process of recalibration of the Sonus PD Alert. Set date and time. This allows the user to amend the date and time of the Sonus PD Alert to compensate for time zone changes or daylight savings adjustments. Once the time has been updated, the Sonus PD Alert will need to be restarted to confirm this update. Factory reset. The user can reset all of the Sonus PD Alert settings to their default values and undo any changes that the user has made. A factory reset cannot be undone. All setup information, including mobile number and SIMs setup, will be lost. Historical data and alarm logs will remain, however. The Info submenu contains information regarding the Sonus PD Alert's conditions, such as last calibration. This is the date of the last calibration carried out by a qualified IRISS engineer. Environment. This screen displays information gathered from the inbuilt temperature and humidity sensors. These values are also sent out with the SMS alerts. About Sonus PD Alert. This screen displays information about the Sonus PD Alert's firmware version as well as the serial number for this device. Appendix 1. Sonus PD Alert SCADA interface. The Sonus PD Alert Partial Discharge monitoring system has two alarm outputs that can be used to interface with the SCADA system. Alarm 1 enables the monitoring system health alarm, which indicates system faults on a Sonus PD Alert, including loss of power to the monitor. Alarm 2 is for partial discharge alarms, and this will indicate PD was detected above preset thresholds on any of the Sonus PD Alert's TEV or AE channels 1 through 3. Each alarm has 3 connections: normally closed, common, or normally open. Connector type. Connections to output is via a pluggable 3.5 mm screw type connector supplied, and the rating is volt-free contact DC ratings are as follows. Current rating is 6 amp and voltage rating is 250 volts. Let's go over the commissioning procedure for your Sonus PD Alert. Installing the battery is pretty simple. The Sonus PD Alert should be powered down. You'll need to remove the 8 screws that are securing the rear cover and remove said cover. If the unit has no battery fitted, fit the battery into the battery compartment and connect the battery to the electronics. The battery compartment is in the top left-hand corner of the Sonus PD Alert enclosure. Fit the battery into the compartment using the foam insert to secure it into place. When connecting the wire from the battery to the electronics, make sure that they are connected with the correct polarity, red for positive, black for negative. Installing SIM card and aerial. Put a SIM card into the SIM card slot on the GSM module and fix the aerial. Gently lift the GSM module off the main electronics board. Again, be sure to wear anti-static gloves and grounding straps. Turn the GSM module over and open the SIM card holder. Insert the SIM card with electronic contacts facing down. Close the SIM card holder and carefully replace the GSM. Installing the aerial. Fix the GSM aerial on the side of the Sonus PD Alert. Replace the rear cover of the unit. Turn the Sonus PD Alert on. A larger aerial may be needed if the signal cannot be picked up in the position that the unit was installed. Sonus PD Alert Troubleshooting. While highly unlikely due to the Sonus PD Alert's robust design and its ability to operate in remote locations for extended periods of time, it is possible that the Sonus PD Alert may require troubleshooting from time to time. If you experience the Sonus PD Alert is not functioning as intended, there are a few things to check out to see if it is possible to bring the unit back online without IRISS assistance. Refer to the troubleshooting guide found in your user's manual.